In this video, we'll talk about solving advanced trigonometric equations. Now, for this video, you're going to want to have checked out the videos regarding trigonometric identities. There should be two of those. Both of those will be very, very useful in solving these. It's kind of the pinnacle. You're using all of you know about trigonometric expressions, their identities, how to manipulate them, and you're also using a lot of the algebra skills you've been developing for years. So we'll walk through a couple of examples here in this video to kind of let you practice, but every single one of these is a little bit unique, and you kind of have to play with it in order to solve the equations. So let's take a look at an example really quick. What I have here is 4 sine squared of x plus 1 is equal to 4. So much like what we do when we're solving for a variable, we want to get x by itself. And I think that the best way to do that first would be to subtract 1 from each side. So we're going to have 4 sine squared of x is equal to 3 if I subtract 1. And then likewise, we'll want to divide both sides by 4. So we'll have sine squared of x is equal to 3/4. Now, if we look at sine squared, what that means is that I have sine times a sine is equal to 3/4. So in order to undo the square, I would take a square root of both sides. So if I do that, I will have sine of x, if I do the square root, is equal to plus or minus the square root of 3/4. Now, when we take a square root, we have to be very cognizant of that. We have to also consider the negative case. And then, to get x by itself, this is where we do our inverse sine, or arc sine, whichever one you prefer. So x is going to equal the inverse sine of plus or minus the square root of 3/4, which is very complex for a solution, and we may want to test both of those and make sure that they do work. Make sure that we do get a real solution, but at the moment, that would be how we would solve that. Notice how this is using your knowledge of trig, but also your knowledge of algebra. It's using everything we've developed up to this point. So just take each one of these slowly. Think about, okay, how can I get x by itself? Let's look at another one. This one's a slightly different example in that now I have multiple trigonometric expressions. So a good rule of thumb here is to try and get all of your trigonometric expressions onto one side of the equation, and then hopefully we can do some simplifications or some factoring or something with our algebra skills in order to solve. So the first thing I'm going to do is I'm going to subtract 3 cosine of x from both sides. And what this will do is I will have cosine of x times sine of x is equal, or is not equal to, it'll be sine of x minus 3 cosine of x is equal to 0. Now this gives me a number on the right side of the equation that I can work with, and it also makes it to where I have this expression here, and maybe there's something I can do. And you may notice right here, okay, I can't really combine these things because I have sine of x times cosine of x minus 3 times the cosine of x. I can't really combine them. They're not like terms. However, I'm looking at both of these and noticing they both have a cosine of x in common. So if I do some factoring, some reverse distributive property, I can think about this as cosine of x times the quantity of sine of x minus 3 has to equal 0. So if I was to work this backwards and distribute this cosine back in, it would still result in the same equation. I'm just doing distributive property backwards here. That's what I did. Now you may recall back from quadratic equations when we factored zero product rule. If I have a product of two things, if a times b equals 0, then one of the two must be 0. So at this point, I have cosine of theta times this sine of x minus 3 is equal to 0. Therefore, one of these two must be 0. or potentially both. So this would tell me cosine of x has to equal 0, or sine of x minus 3 has to equal 0. And then I can solve both of these individually. So if we think about this, if I was to do inverse cosine, we could say, okay, x is 1. We know that one to be true. Or not 1. X would have to be 90 degrees. Or it could also be 270 degrees. Because if we think about cosine, it's the x-coordinate, and that happens at 90 degrees and also 270 degrees. So that's kind of that half of the equation. Okay, and now I'm going to look at the sine of x minus 3. Well, the first thing we ought to do is we ought to add 3 to both sides. So we have sine of x equals 3, and then we have to do the inverse sine. So x would then equal inverse sine of 3. And I'm not sure what that is off the top of my head, but I do know we would get one answer, and then we'd have to consider the unit circle, where that lands, and since we're looking at height with sine, it's probably going to result in a thing. Or it could be possible, actually, since this is a 3, there's no way I can have a height of 3 on this unit circle, especially since the radius is 1. So this part, there'd be no solution if we were to think about it. Now, yeah, if this wasn't a 3, if it was 4/5, then yes, we would use this unit circle idea, and we would have to work out multiple trigonometric solutions, as we would when we're solving trigonometric equations. However, since this results in a 3, and if we do inverse sine of 3, we get no solution, your calculator will throw up an error message. That only leaves us with the 2 options here on one full rotation. Now, we could obviously add any multiple or subtract any multiple of 360 degrees to both of these. And that would give us a solution set, because if we think about a trigonometric expression, if we look at coterminal angles, then we have to consider the possibility of 540 degrees and so on and so forth. Every time that I do this rotation around and I stop at the top and the bottom, that is where this equation will be true.